Okay, so this is about section 4.8, which is Newton's method. So what Newton's method is it's a way of finding a root of a function. When I say a root, I mean where the function is zero. So let's say I'm trying to find this point, and I have some approximation. Like I have this point, which is, not really that close, so it's not a great approximation. Newton's method is a way of getting a better approximation, and the way you do it, let's see, do I have a red pen? You draw the tangent line, and as usual, it looks like the tangent line kind of follows the function pretty closely. And then you just find the root of the tangent line, which is not exactly going to be the point that we're looking for, but this point is closer to what we're looking for than this point was. And the nice thing is you can do this again. Now that we have this point, you can do it again and get an even better approximation. And the idea is that you keep repeating this and you get closer and closer to the point that you actually want. So there's a formula for this point, the red point down here, and basically I derived it down here. Here is, if you remember, the formula for the linearization L of x. This is also known as the tangent line. This is the formula for the red line. And the red point is just where that line hits zero. So if I take that and set it equal to zero, and I didn't really show the work, but if you take this and you set it equal to zero and solve it for x, you will get this. And notice the name that I gave our initial point was x sub old and y sub old. The idea is, again, we're going to make a better and better approximation. So typically we call the next one, we call this x sub new. Right, it's like this is our old approximation and we use it to make our new approximation. Right, let's use this to approximate the square root of 5 to 3 decimal places. Of course, we all have calculators that can do this, but let's not just put square root of 5 into our calculator. Let's see how Newton's method works to do this. So first of all, what Newton's method is good for is to find roots of functions. So let's find a function that this is a root of. That's pretty easy. X squared minus 5. Of course, if I put in the square root of 5 here, I would get 0. So it's easy to come up with that function. So let's call that f of x. We need some initial approximation, and then we'll probably make that better several times. I'm going to come up with a guess that I think is close to the square root of 5. It doesn't need to be that close, so I'm not going to try that hard. I'm just going to say 2. The square root of 4 is 2, and 5's not that far from 4. It doesn't need to be that close. We'll just start with 2. And I'm going to call that x sub 0. And then the next one is going to be x sub 1, and then the next one is going to be x sub 2, and so on. So let me tell you how I calculate these. Right, x new is x old minus f of x old over f prime of x old, like that. Of course, f of x is just this. So, right. F prime would be 2x. So it's like I've got this. So I can start doing these. X sub 1 would be, I just plug in 2 for x sub old, so it would be 2 minus 2 squared minus 5 over 2 times 2. And when I do that, I get 2.25. And now I can find x2 by just taking my last answer and plugging it in here. And when I do that, I get 2.236. And now, yeah, it would be good to pay attention to the instructions. We're trying to do this to 3 decimal places. My first one was just exactly 2. This one was exactly 2.25. This one I'm rounding. Actually, my calculator is telling me that there's actually a bunch of 1s after this, but I only want it to 3 decimal places, so I'm just going to leave it like that. And how do I know when to stop? Because I mean, I could go forever doing this. If I want it accurate to 3 decimal places, what I'm going to do is I'm going to keep going until it gives me the same answer, at least up to 3 decimal places. I want to see it give me the same answer twice, and then I'll be sure. So the next one would be 2.236 minus 2.236 squared minus 5 over 2 times 2.236, right? And yeah, you know, at this point I'm getting tired of writing, but when I do that, I get 2.236 again. So I'm already there. I got the same answer twice. So that's it. Good. By the way, I forgot to talk about this up here, but there's some ways that Newton's method can fail, and I need to make sure to talk about this because there's an online homework question about it. For example, if you choose a point, like if my x old, y old was up here, then I would draw the tangent line, and it's just horizontal. If I'm looking for where the red line crosses the x-axis, it never does. And also, this would be a problem. If I try to use this formula, I would also be dividing by 0, because f prime would be 0, because we're looking at a horizontal tangent line. So if your approximation happens to be where there's a horizontal tangent line, then that's bad. One way to fix that is to just use a slightly different point for your initial approximation. Because if I had used a point a little bit to the right or a little bit to the left, at least it wouldn't be horizontal anymore. So that's one issue, is a horizontal tangent line. There's also another issue, because I mean, this picture is actually really bad for a number of reasons. Another issue is that it has a horizontal asymptote at 0. Because if you look at what's going to happen, I mean, first of all, you can see this function never crosses the x-axis. And Newton's method is good for finding where it crosses the x-axis, so we're never going to find anything. We're not going to find what we're looking for because this function never crosses the x-axis. But let's examine what would happen if I tried to run Newton's method on this. We know that starting with this point doesn't work, so maybe I'll start with a point slightly to the right. What would Newton's method do? It would draw a tangent line, look for where that crosses, and then now this is my new point, so I follow it up. I draw the tangent line there. I look for where that crosses. That's maybe about here, and then that's my new point. I follow that up. I draw a tangent line, and of course my picture is getting pretty cluttered now. my tangent line is almost horizontal, but not quite because this keeps decreasing. So, but maybe you can see what's going to happen. Newton's method just keeps giving us a point that's farther and farther to the right. And the function is getting closer and closer to zero, but it never hits zero, so we never find a root. We just keep moving farther and farther to the right. Similarly, if we had started to the left, then we would just be moving farther and farther to the left. So these horizontal asymptotes at zero are bad for Newton's method. Okay, so now that I've talked about that, let me just do another example. Starting with x naught equals 2, let's use Newton's method to find approximation x sub 2 for the root of this equation, e to the x equals 5x. Yeah, so I wanted to do this one just because this is not set equal to 0. This is very easy to fix. Newton's method is for finding where a function equals 0. So if you are asked to use Newton's method to find a solution to an equation that's not equal to 0, you can just subtract everything over to one side, so that way it will be equal to 0. So yeah, my function is going to be e to the x minus 5x. If I find an approximation for where that's 0, that'll be an approximation for when this is equal. Yeah, and this is it's the same formula. X sub new is going to equal x sub old minus, okay, I'm using this formula. So f of x sub old, that would be e to the x old minus 5x old. I would divide that by f prime of x old. F prime would just be e to the x minus 5. So e to the x old minus 5. Yeah? So x sub naught was 2, so x sub 1 is going to be 2 minus e to the 2 minus 5 times 2 over e to the 2 minus 5. So I have to put that in. And I get, yeah, so actually let's say, we're rounding to 3 places. So what I get is 3.093, and I did round it off. So to get x2, it's going to be the same thing again, except I plug in this number, 3.093. So x sub 2 is going to be, I use this formula and I plug in this number, and what I get is 2.701. And again, I'm rounding off because it's just accurate to 3 places. And that's all we need to do. The question just asked for x sub 2. So on some of these questions, it'll ask specifically for x sub 2 or x sub 3 or something like that. On other questions, it's not going to tell you exactly how many steps you need to take. It's going to say we want the answer accurate to a certain number of decimal places, meaning that you just have to go and go and go until you get the same answer twice, and then you're sure that that's the answer. But yeah, so that's Newton's method.